Um, Today we're going to look at double angle identities. So double angle identities, we're saying sine of 2 alpha is equals to 2 sine alpha cos alpha. Then cos of 2 alpha is equals to the three identities. So the cos double angle identity has got two identities. It has got three identities. But let me show you where they come from, these double angle identities. So sine alpha, let me start with sine, where it comes from. Sine 2a. We want to know where it comes from, its double angle identity that we see here. So actually, it comes from the compound angle identities. So we say sine of compound angle identities, we say first angle plus the second angle. So in this case is sine of alpha plus the second angle, which is alpha again, so that it forms 2 alpha. Right? Now we apply the compound angle identity of sine. The compound angle identity of sine, we remember it is C Q C. So it is going to be sine alpha cos alpha plus cos alpha, then sine alpha. Right, looking at this, I can change this order here, so that because this and this are actually the same, so I'm saying this thing here is exactly the same as this. The difference is just the order. So this starts with cos instead of starting with sine. So this one here can be written as sine alpha cos alpha, so that it's the same as that in order. So now I say this is sine alpha cos alpha. So here I'm repeating, I'm still rewriting this here. I'm still rewriting that. Now plus cos alpha, plus sine alpha. So I'm just changing the order here. So it is just sine alpha cos alpha. Right, let me use the one that is visible. Enough. So it is plus sine alpha cos alpha. So this and these are like terms. So it is 1 cos alpha sine alpha, 1 sine alpha cos alpha. So they will form 2 of them. When you add them together, they are 2. So this is what? Sine what? Sine 2a. So sine 2 alpha. Sine 2 alpha is equal to 2 sine alpha cos alpha. Right? So let's find it. So hence, that's why the double angle identity, we have it like this of sine. Now let's find out where the 1 for cos comes from. How do we derive the 1 for cos? Now the double angle identity of cos, saying, right, if I have cos of alpha plus alpha, so that will be 2a, that will be 2 alpha, right? A alpha plus alpha forms 2 alpha is equal to, remember the pattern, the compound angle identity of cos. The compound angle identity of cos is CC. Remember, for sine we say C C cis for sine. That is for cos now. Cis is for cos. So it's going to be cos alpha, then subtract sine alpha. The reason here I subtract, I said, remember for cos, if you are adding angles, then you must subtract the trigonometric ratios. That is for alpha. Right, this is equal to cos multiplied by cos will become cos squared alpha. Sine multiplied by sine will become sine squared alpha. So the first identity has been derived like that. The second compound angle identity, you find it by saying, remember, we know this the square identity. We know that cos squared alpha plus sine squared alpha is the same as 1. Therefore, if I transpose cos, then this is equals to 1 minus sine squared alpha. So now, alpha. I'm going to replace there. I'm going to replace this cos alpha with this, right? This is the same thing. So this is equal to, for the second compound angle identity, right, it will be 1 minus sine squared alpha, and we also have minus sine squared alpha there. Now minus sine squared becomes what? 2 sine squared alpha, and that is the second compound angle identity. So this was the first, this is the second compound angle identity. For the third one, we do this. Instead of transposing sine to the other side, now we transpose alpha cos to the other side, so that you are going to have sine squared, you are going to have sine squared alpha is the same as 1 minus cos squared. Now we are going to replace here, we are going to replace the sine squared instead of replacing the cos squared. So this will be cos squared minus 1 minus cos squared alpha. Then multiply into the brackets, you have cos squared minus 1 plus cos squared alpha. Remember, now combine like terms. This is 2 cos squared alpha minus 1, and that is the how we get the third compound angle identity. Sorry, double angle identity. Yes, so that's how we find them. right? So cos has got 3 double angle identities. Sine has got only one double angle identity. Now the double angle identity of cos, this one here, the first one, it is a difference of 2 squares. Cos square minus cos square, difference of 2 squares, which can be factorized in this way. That is another information that is you need to know as far as these compound angle identities are concerned. Right, let's look at the determine without using a calculator. So what do I have here? I look at this pattern here. This is sine of an angle, cos of an angle. So this follows 2 sine alpha cos alpha, which is the same as what? Sine 2 alpha. It is the compound, it is the double angle identity of sine. It follows the double angle identity of sine. So therefore, I can say this follows, it says sine of 2 times 2,25 degrees, which is equals to sine of 45 degrees. You punch sine 45 degrees in your calculator, you get root 2 over 2. You get root 2 over 2 is your answer. Then that's how we do that one there. The second one, if you look at it, this follows cos squared alpha minus sine squared alpha, which is the double angle identity of cos, which is the same as 2 alpha. Let's check. So I'm saying it relates to this, it relates to that. Remember that side we're having cos squared 15 minus sine squared 15. So our alpha is 15 in this case, which is the double angle here. I mean, which this relates to the double angle. So this is what? This is the same as what? Double angle identity of cos. So cos of 2 times 15, which is cos 30. And cos 30 in a calculator, root 3 over 2. That's how you would have done that one there. So this is what I'm talking about. So I'm saying this relates to that. This is how you do this one. You take it back to the cos of 2 times 15. Then this is cos what? 30. Cos 30 is root 3 over 2. Right, we look at the second one. This one also relates to the double angle identity of sine. Remember, the double angle identity of sine is 2 sine alpha cos alpha, right? So this as well, it is 2 sine 15 cos 15. cos 15. It's just that instead of putting 2, they've put 4, which means they've multiplied by 2 actually. So I write 4 as 2 times 2. Then you will realize that this part now is the part of compound angle identity. Sorry, double angle identity of sine. So the 2 is still there, this one. So this part here is the double angle identity. So this part, it is changes to sine 2 times 15 degrees, which is equals to 2 sine 30. And this is therefore sine 30 in the calculator, it is half, then 1. Then we have simplified it in this way. Again, if we look at this one here, determine this. This follows the pattern of double angle identity of cos. The second one, we said cos of double A is equals to 1 minus 2 sine squared A. It follows that double angle identity. So therefore this one here is the same as saying sine, sorry, not sine, it is cos 2 times 2 5 degrees. And this is equals to cos of 45. Then cos 45 in our calculator, it gives us root 2 over 3. Root 2 over 2. And that's how that one is simplified. Right, we look at this one. This still relates to the double angle identity of sine, but we don't have that 2, so we'll put that 2 there, and then so that it makes 8 now. So it is actually 2 sine 25 cos 25 degrees. But we know that in front here there is what? There is 8, which means the 2 was multiplied by 4 to form that 8. Then over sine 50. Right, therefore I know that this part here is the double angle identity of sine. This part there. So still have 4. Then this part here changes to the double angle identity of sine, which is sine 2 times 25. All over sine 50. This is equals to 4 sine sine 50 over sine 50. Now sine 50 cancel sine 50, then the answer is 4. Now they say determine this. If I look at this angle, this is an angle bigger than 90, so it must be reduced. This is an angle bigger than 90, it must be reduced. This is an angle bigger than 90, it must also be reduced. So now when I do reduction, I use the arc method. So in my calculator, I'm going to say for this one here, I'm going to say shift sine of the 300 degrees. Then I'll get the answer.
Black Label, the official beer of the FIFA World Cup 2026. This is it, the real thing. You can already taste the reward. Here's to Africa's most awarded beer. Carling Black Label, the official beer of the FIFA World Cup 2026.
Which is the 340.
Carling Black.
So when I do this, I said I got 20. Now the negative goes to the trig ratio. This goes to the trig ratio, and this replaces the big angle there. So this is what? This is now sine of 20. But remember, I got negative 20. The negative sign goes to the trig function. Then cos negative 200. I punch it in the calculator in the same.
Of the FIFA World Cup 2026. Champions deserve champion beer. Carling Black Label, the official.
Get positive.
A beer made with 2 specialty malts smashed together by wrestlers. It's true.
It's not reduced to the bottom line. So since it's not reduced in a way that it is
A beer made with 2 specialty malts smashed together by wrestlers. It's true.
subtract 130 from it.
A beer made with 2 specialty malts smashed together by wrestlers. It's true.
So in other words, now I got negative 20. So negative 20 cos theta. So the negative goes to the trig function. Close brackets. Then for sine 140, you go to the calculator again and you arc it. So when you arc it, you get 4.
A beer made with 2 specialty malts smashed together by wrestlers. It's true.
So now this is what? This is the same as sine 40. Now negative sine 20 times negative sine 20 cos 20. Negative and negative form positive. So this is sine 20 cos 20 over sine 40. So we can see that this relates to a double angle identity, because if I check, you see 40 is the double of 20. See, so I must take it back to the double angle identity. So what I will do is, for it to be the double angle identity, the double angle identity of sine, it says 2 sine alpha cos alpha is the one that is equals to sine 2 alpha to the sine 2 alpha. Now, in this case, I don't have that 2 in front. So I put it top and bottom. When I put it top and bottom, it means I want now I put the 2, but I also divide it by 2 so that the coefficient is still the same as 1. Right? So now this is changing to the double angle identity of sine that we know. Right? So now you're going to say this is equals to sine 2 multiplied by 20 degrees all over 2 sine 40, which is equals to sine 40 over 2 sine 40 degrees. Then sine 40 and sine 40 cancel. The final answer is 1 over 2. So that's how we would have done this one day. Answer that one day. So let's go to the next one. The next one says to us, simplify to a single trigonometric ratio. Now, this one we're going to see, say how 190 change shall be. So you change the 90. When you make the 90 disappear, we're going to drop the 90. Remember, if we see 90, 180, then 360, we drop them. But when you drop 90, the trig function changes. Cos changes into sine, and sine changes into cos because it's co-functions. Now, so this is no longer sine because of the 90. So this is now cos squared y. And if the trig ratio is squared, you don't need to determine the sign of the trig ratio because it will always be positive. When you square a number, it's always positive. Then you say plus. Now this, you drop the negative sign. You drop this negative sign. So just like you drop the 180, 360, and 180 and 90. So this is sine y. Now I check in the calculator whether it is positive or not. In the place of y, I put you put 1 degrees. So that's what I will do. So in the place of y, I've put negative 1 degrees. I've put 1 degrees there. Then the answer is negative, which means the trig ratio is the one that is negative. Remember, 1 degrees, we use it to determine the sign of the trig ratio.
A beer made with 2 specialty malts.
So now this is what? Negative sign. Now for cos, how 190 change so you for cos you change. Now it changes to what? To sine. So this is sine y. You determine whether it's positive or negative, whether the trig ratio is positive or negative by substituting 1 degrees. So if I substitute 1 degrees there in the place of the variable angle, you get a positive answer, meaning now this is positive answer. The trig ratio is positive. So it's positive. So now if I multiply these two, this is minus sine squared y, and this is cos squared y. Now this relates to my double angle identity. It relates to the double angle identity of cos. So this is same as 2 cos of 2y. So I've written it as a single trigonometric ratio. So the final answer must be is one type of trigonometric ratio. Then this one, we drop the 360. We drop the 360. So this is sine A. That will only leave the variable angle. So this is sine A. Now you determine whether it's positive or negative. You replace by replacing the variable angle with 1 degree. This is what I'm doing here. This is the one that I'm treating. So the answer comes out positive. So the trig ratio is positive. So it's positive. Then our 190 change shall be, so you change this into what? Cos A. You determine whether it's positive or not, and you'll discover that it is actually positive. Then plus, now do this. You drop the minus sign, it becomes sine A. Then you check if it is positive or not. So in the place of A, I put 1 degrees, and I get a negative. So sine, meaning the trig ratio is negative now. So this is negative. Negative. Then cos 900. Here, this is 900. So if it is 900, it is an angle greater than 360. So from you subtract 360 until you get 180, or you get 360, or you get 90, so that you can drop them. So let's do that in the calculator. Subtract 360 from it. So you subtract 360 is 540. You subtract another 360, it becomes 180. Now this means the 900 is the same as 180. So here is like they have put 180. Then you drop it. This is what cos A. Then determine whether it's positive or negative. So I say cos 900 plus 1 degrees. And it's meaning the trig ratio is positive, is negative. So this is negative. Put that answer there. Now this is, now we can say now this is sine A cos A. Multiply negative and negative from positive. So positive sine A cos. You add these two, they are like terms. So this is 2 sine A cos A. But they said we must write it to a single trigonometric ratio. We must simplify it to a single trigonometric ratio. So this is the double angle identity of sine. So this is the same as sine 2 times a. Now we're going to look at proving identities. We only have one double angle identity for sine, but for cos it involves three. So how do you change them? How do you use each? So when the double angle identity of cos is close to or adjacent to, when it involves cos A only, you choose the one that has got cos only, the double angle identity that has got cos. So meaning now this will change to that. Now if it involves sine A, then you need to change this to sine only, to the one that has got sine only. Because now if it has sine and cos, if it involves sine and cos, then the double angle identity they should use is the one for is this one, that one that has got cos and sine. Again, if now you have got cos of double A close to sine 2a, to the double angle identity, now you know that this one will be converted to 2 sine A cos A. So it means now this must be changed to the identity of cos that has cos and sine. So it must be changed to sine squared A minus sine squared A, if it is close to the double angle identity of sine, which is different from this here, this situation here. So this is what I'm saying. So we are comparing, check, cos 2a, saying cos 2a involves sine 2a. So this is a double angle identity of sine, which is simplified to 2 sine A cos A. So this cos must be changed to the one that has got sine and cos, to this one there. It must be changed to this. It must be changed to that. Because this is double angle identity of sine, which involves cos and sine, which simplifies to cos and sine. Unlike when you have a single identity, sine of a single angle. Sine of a single angle, then it corresponds to the one that has got sine only. Right. So let's look at it. An example. So how will you change this one here? The first one, if they say simplify. So this cos, which identity do you choose? Because it has got 3 double angle identities, right? It has got 3 double angle identities. Remember, cos has 3 double angle. Cos has 2 alpha. Cos 2 alpha is equals to cos squared alpha minus sine squared alpha. it has identity number 2, which is 1 minus 2 sine squared alpha. And it has identity number 2, which is 2 cos squared alpha minus 1. So now, because this double angle identity, it involves what? Sine only. Then I change it into the one that has got sine only. I change it into the one that has got sine only. So this, when it simplifies, this now will become, this is sine x minus 1 minus 2 sine squared x then this is sine x minus 1 plus 2 sine squared x, which you can also put it you can say this is 2 sine squared x plus sine x minus 1. Simplify as that, right? If possible, you can factorize it, but yeah, let me leave it here. Then now, how will you simplify this other one? So here you've got, how do you change this double angle identity? Of course, this one involves what? Cos only, right? So this one changes to the one that has got cos only. So this one here, you change it into 2 cos squared b minus 1 plus cos b, which you can put it nicely as 2 cos squared b plus cos b minus 1. And if possible, you can factorize it if it is factorizable and if it is necessary to do so. But for now, leave it like that. Simplify. Then we check this one here. So you have cos A now. Check this cos A now. At the bottom, we have got sine A cos A. So you change this into the one that has, into the first one that has got cos and sine, because there is cos and sine there. Right, so this is equals to, it changes to cos squared A minus sine squared A over sine A plus cos A. But remember, this was nothing. But remember, this is a difference of 2 squares. This is a difference of 2 squares. So to factorize it, it can be factorized like this. So this is cos A sine A, put minus there, cos A plus sine A. All over minus sine A plus cos A. So now check this. So this one here and this one can cancel this. You'll be left with what? You'll be left with cos A minus sine A. Right, check the one for sine. This one has got one identity, which is 2 sine A. It changes to sine A cos x. Now they say you must prove. Actually, the question was supposed to say prove. You're proving. So remember tan. If something is equal to tan, remember tan is sine divided by cos. So in the denominator, so we want now, when I prove, if I want to prove that this whole thing is equal to tan, I know that tan has got cos in the denominator. So here the aim is to have cos in the denominator. So I must remove this sign here if possible. Must remove that sign there so that I remain with cos. So when I change this, I change it to the called double angle identity that has got this double angle identity here. I must change it to the one that has got what? The one that has got cos. So I must change it to the one that has got cos in it. Not cos only, but sine, so that the sine will be removed. So here I'm going to change it like this. This, I change it into this identity here, so that this sine here can be removed by this sine there. And then you'll be left with cos. The aim is to get cos in the denominator because tan is sine over cos. So this is 2 sine x cos x over sine squared x plus cos squared x minus sine squared x is our left hand side. Now this and this will cancel. So I've got 2 sine x cos x over cos squared x. Now one cos will cancel with the other cos there. So you'll have, so this is what I am saying. I am saying cos squared is the same as cos x multiplied by another cos x. So one cos x will cancel with the other cos x. So you'll have 2 sine x over cos x, and this is equals to 2 tan x. Then the identity would have been proven in this way. So yeah, so we're looking at this one. We must change this to, we must choose from this double angle. This is the double angle identity, of course. Choose from this or that. So let's see what we can do. All right, so we change this one to the one that has got cos only, because it is closer to cos, it involves cos, so we choose the one that has got cos only. So we change it into the last one there. Then we change this obviously to that. So let's start. So we change it into 2 cos squared a minus 1 plus cos a. All over 2 sine a cos a minus sine a. Now going to factorize. Now this is going to be open 2 brackets. We're going to have 2 cos x, because this is quadratic, minus, okay. Now you put 1 there, put minus there. All right, in the denominator I take out the common factor, which is sine a. So sine a is equals to 2 cos a minus 1. Then this and that cancel. Left with cos. So I've been writing x is a. So left cos a as 1 over sine a. And it's proven. So this was a quadratic. It is in the form cos squared a plus cos a minus 1. That was this when you rearrange it. Now look at this. So at the bottom we have got cos A minus sin A. So this gives me a clue that this must be changed to the one that has got cos and sine. So the first one, the first compound angle identity, double angle identity, so to say. So say this is the same as cos x minus sin x squared all over cos x minus sin x. Now you factorize difference of two squares. This is the difference of two squares. Open the brackets. Cos x sin x cos x sin x. We put different signs over cos x minus sin x, and this and that cancel. Left with cos x plus sin x. Right, this is sin x plus 2 sin x cos x, 2 sin x cos x. Right, we start from the left hand side. All over 1 plus cos x plus. So this one is close to what? To cos only. So I change it into the cos only identity. So it would be 2 cos squared x minus 1. Then 1 subtract 1 out. In the numerator, I'm going to take out the common factor, which is sin x. Sin x 1 plus 2 cos x. This is quadratic. Oh, this is cos x plus, or the same as this is cos squared x line plus cos x. Take out the common factor in the denominator. So sin x over 1 plus 2 plus x. Common factor is cos x. So you remain with 2 cos x plus 1. And this cancel. you're left with sine over cos. So this and this cancel, you're left with tan what? Tan x. Left hand side is equal to the right hand side. Now this is 1 plus 2 sine a cos a. Over this one, I change it and write it in terms of cos and sine, because I can see the clue there, that side, there's cos and sine. So I write it to cos squared a minus sine squared a. Now the one, I change it into cos squared a plus 2 sine a cos a plus sine squared a. Then you open two brackets. Difference of two squares in the denominator. Cos a sine a minus cos a sine a plus. Then we factorize. So we know this type of factorization that says x squared plus 2xy plus y squared. When you factorize this, this is open brackets x, then y, y. So going to follow the same. Yeah. Open two brackets. That's a. That's going to be not sine squared, sine a. When you put positive signs. A. Right, like terms here. So this is must be positive. Because here is positive, right? So this and this cancel. And then we have proven the identity. And then until so this is how we apply double angle identities, boys and girls. Until we meet again for today, thank you.